In this video, I'm going to look at one sample hypothesis testing. The version of JUMP that I'm using to do this is JUMP version 12. Now this data set contains the results of a single group of students who were looking at a bag of M&Ms and counting how many blues there were. In their bag, there were 55 M&Ms and 10 of them were blue. I have recoded the color into a dichotomous variable, either a 1 or a 0. And when I start doing the hypothesis testing, I'm going to look at the numerical version of the variable. So the background to this is that Mars, who make M&Ms, used to claim that 24% of the M&Ms in a bag on average were blue. So we want to see whether or not the data we have observed is concordant with the claim of 24% blues. So let's have a very quick look at the data itself. So analyze distribution. I'm going to have a look at the numerical version of the variable, coded as 0 or 1. Histogram isn't very useful, but if I go down here and look in the summary statistics, I can see 0.18. That's 18% of this sample were blues. I've got a standard deviation and also the standard error of the mean, which is simply the standard deviation divided by the square root of 55, s over square root of n. Now with this information, we can create a confidence interval, and the confidence interval is here 0.0765 to 0.287, and you could answer the question whether or not 0.24 was a feasible value for the population proportion simply by seeing whether or not 0.24 lies in the interval, and it does. So based on the confidence interval, we've got no evidence against Mars's claim of 24% blue M&Ms. But I wanted to show you how to do formal hypothesis testing, and if we want to test specifically whether or not the population proportion is equal to 0.24, we can right click on the title bar up there, and the dialog is test mean. Now what we're going to do in here is type in our value for the mean, which is 0.24, that's our null hypothesis value, and we will just let the standard deviation be calculated from the data. I click on OK, and this is the output that I want to have a look at now, the output at the bottom of the page here. And I can see, as I scroll down, the output from the test, the hypothesized value is 0.24. The actual estimate is 0.18, 18%. The standard error, we know that is 0.05, so we get our test statistic, our t-stat, by doing 0.18 minus 0.24 divided by the standard error, the 0.05. And that gives us an event that is just a little more than one standard error away from where we think it would be under the null hypothesis. That's what's shown to you in the graph down here. The blue line in the middle is the null hypothesis value of 0.24. The bell curve, the normal distribution, is based on the central limit theorem idea, the sampling distribution of the p-hats of the observed proportions, and the one that we have observed is this one that's given by the red mark at 0.18, so that's about 0.18, and we're just saying how far away is the red line from the center blue line, and the answer is it's about 1.1 standard errors away. Now, is that a statistically significant effect? Well, we can compare the test statistic to the approximate cutoff values, plus or minus 2, and we notice it's not more extreme than minus 2 or plus 2, therefore there's no evidence against the null. Or equivalently, we can look at the p-value here, and the first one of these is what I want to concentrate on. It's called the two-sided p-value, and here it's 0.27. What that 0.27 is telling you is that the area that corresponds to more extreme values of the observed proportion is equal to 0.27. So the shaded blue areas under the test statistic graphic are in fact the p-value. So the probability that if the null hypothesis is true and we were to do the experiment again, we'd observe something more extreme than we did the first time. And we didn't specify whether we were going to have a proportion that's less than 0.24 or greater than 0.24 a priori. That's why we've done a two-sided test here. We're summing these two areas to get the p-value of 0.27. Now we can apply the p-value rule. Is the p-value less than 0.05 to make our decision? And it's not less than 0.05, therefore there's no evidence to reject the null. And that's how you can use the JUMP dialog to do a formal test on a mean. And here I'm doing a test on a proportion. Now, as I'm talking about proportions, it is possible to use a different dialog, and this is specifically for proportions. If you go to the version of the variable where it is coded as a nominal variable, note the red bar chart there, and you go to Analyze and Distribution, now the variable is no longer being treated as 0, 1, but as a category, blue or not blue. We can look at the percentages here. There it is, 18%. Didn't change the proportion of blues, but 18% of them are blues. But through this dialog, we have a couple of alternative ways of getting at a confidence interval and a test. If we right-click on the title bar, we can ask for a confidence interval. Let's do 0.95. And we can go down here to the confidence interval output. You can see it. And here in the output is a confidence interval for the blue proportion. The lower end of the interval is 0.1, the upper end is 0.3. And so if you look carefully and compare it to the one that we had just calculated, so I'll just bring that one back again quickly, and we have a look at the confidence interval over here. Our confidence interval was 0.07 to 0.287. So it was pretty close, but not identical, and the fact is that this methodology is slightly different in terms of calculating the confidence interval. Whenever you have a reasonable sample size, it's not going to make a material difference, but that's an alternative confidence interval for the proportion. And also you can use this dialog to test a probability. So let's go into test probability and type in down here our null hypothesis value of 0.24. At the bottom, it's asking what type of test, two-sided or one-sided. I'll stick with the two-sided test and click done. And then we get an alternative methodology for calculating whether or not we have a statistically significant effect. So in terms of the output here under the test probabilities, our null hypothesis for blues was 0.24. We observed 0.18. And these are alternative methods for calculating the test statistics. And we can see that the test statistic is technically called a chi-squared here. It's a little over 1, but if you have a look in the column that says prob greater than chi-squared, you're looking at your p-values again. And you can see the p-values of both, regardless of how it's calculated, 0.3. And so we have no evidence to do anything other than go with the null here. We fail to reject the null hypothesis. There's no evidence from this data that the proportion of blues in the M&Ms is anything other than the original claim of 24%. So you've seen alternative ways of calculating these confidence intervals and test statistics in the case of a proportion, but typically you can just treat the data as numeric, zeros and ones, analyze, distribution, have a look at the data. You get a confidence interval immediately coming up, 0.076 to 0.287. And if you want to do a hypothesis test, you just right-click, test mean, and you drop in your null hypothesis value and beam down on the p-value, sitting there at 0.27, no evidence against the null hypothesis. So this is what you will typically be doing.